This video series goes through the daily problems in this maths calendar that is published by the American Mathematical Society. You can either purchase it through their website or via Amazon. Today's problem is to evaluate 4 factorial divided by 4 plus in brackets 4 minus 4 divided by 4. Recall that factorial means that we multiply 1, 2, 3 up until the number. So 4 factorial is 4 times 3 times 2 times 1. The only other thing to keep in mind is the ordering of operations. Division and multiplication take precedence over addition and subtraction. Going from left to right, 4 factorial divided by 4 is 4 times 3 times 2 times 1 divided by 4. The 4's cancel, so that's 3 times 2, that's equal to 6. For the right-hand part in brackets, we remember that division has precedence, so we do 4 divided by 4 first, that gives us 1. So 4 minus 1 is 3, and so we end up with 6, which is this part here, plus 3, this part here, because 4 divided by 4 is 1 and 4 minus 1 is 3. Therefore, the answer is 9. What are some examples of when a factorial might appear in real life? In earlier videos, we've actually seen 2 examples. The first is if we expand e to the x, we get 1 plus x squared on 2 factorial plus x cubed on 3 factorial plus etc. That actually comes from the general expression for a Taylor series for a differentiable function, that f of x is equal to f of 0 plus f prime 0 times x plus f double prime 0 on 2 factorial x squared plus the third derivative at 0 divided by 3 factorial and so forth. Why are we getting these factorials in the denominator? Well, roughly speaking, remember if we take x to the n and differentiate it once, we get nx to the n minus 1. Now what if we differentiate it twice? We'd have n times n minus 1, x to the n minus 2. Differentiate it a third time, n minus 1, n minus 2, x to the n minus 3, and so forth. How might we write these coefficients here? Well, let's take this third one, n times n minus 1 times n minus 2. If I want to write that using factorial, the trick is that I simply need to add the remaining terms to the numerator, and the same terms I now add to the denominator to cancel out, and I see that that would be n factorial divided by n minus 3 factorial. Another place where factorials appear is in this symbol here, which means how many ways are there to choose k things out of n, and we've used this before in our binomial theorem here. The rest of the video will explore this symbol here. Let's start with a specific example. Imagine we've got 4 objects. How many ways can we choose 2 of them? For argument's sake, let's assume our 4 objects are called A, B, C, and D. They might represent 4 different coloured balls, for example. First, I choose one object, so I could choose either A, or B, or C, or D. If I chose A as my first object, then I can choose one of the remaining 3 for my second object. So I could end up with AB, or AC, or AD. Similarly, if B was the first object I chose, my second object I could choose either A, or C, or D. If C was the first object I chose, then A, B and D are remaining, so I might end up with C and A, or C and B, or C and D. Finally, if D was the first object I chose, then I might end up with DA, or DB, or DC, and these are all my possibilities. We immediately see that there are 4 times 3, or in other words 12 outcomes that are possible. But note that these are ordered outcomes. I have got over here A and B, and over here B, A. If I'm just choosing two objects from 4, then whether I first choose A then choose B, or whether I first choose B then choose A, at the end of the day I end up with the two objects A and B, and so they should be considered the same choice. When order does matter, we talk about permutations. So we can say if we've got 4 things and we choose 2 of them where order does matter, then the answer we've seen is 4 times 3. And the justification is that if I start off with 4 objects, then on my first choice I've got a choice of 4 things. On my second choice, because I've already used up one of the objects, I now have 3 objects remaining. So for permutation 2 is 4 times 3, and the formula can be written in terms of factorial as 4 factorial on 2 factorial for this special case, and in general n big P little p is equal to n factorial on n minus p factorial. Coming back to combinations, we see we can start off with our ordered permutations here and then group them. So AB and BA is one choice, AC and CA is another choice, and we find that for every ordered pair, such as B and D, there's exactly one other opposite, DB. This means out of the 12 permutations, we actually have 6 combinations, because every permutation comes in a pair, we divide by 2, we've got 6 unique combinations. Now let's look at the general case. We have n objects, we want to choose k of them. How many ways are there? Well, first we choose k things in order. And so the first thing I choose, I can choose out of n objects. My next choice, because I've already chosen one, there are n minus 1 objects to choose from, all the way down to n minus k plus 1. This gives me k terms here, because I've chosen k things. Writing this in terms of factorial, this is n factorial divided by n minus k factorial, because both the numerator and the denominator have got a common terms, n minus k minus 1, all the way down to 1. They cancel, leaving just the terms n minus 1, down to n minus k plus 1. This is the number of ways I can choose k things when order matters. If I have got k things, how many ways can I order them? If I've got 3 things, red, green and blue tennis balls, how can I order them? I can have red first, then green, then blue, or blue, green, red, etc. Well, imagine there are 3 slots. The first slot, I can choose one of 3 balls, or in general, one of k things. The next slot, I can put one of k minus 1 things. The third slot, one of k minus 2 things, and so forth. And so therefore, there are k factorial ways we can arrange k things. Therefore, the number of ways I can choose things when order does not matter is the number of ways I can choose them when order does matter, divided by the number of ways I can order them in, so I get the formula that n choose k is n factorial on n minus k factorial, which is this one, divided by k factorial, which is this one.